Hello, everyone. This is the final set of our course review for Math 1324. This is set 5, and we will cover sections, the last part of the course here, maybe. And the questions we will cover from the course review are questions 45 through 50. So we're displaying the course review there on the screen, and we're displaying question 41. So let's get started. And we have 41 reads perform the indicated operation if possible. So here we're subtracting two matrices, and when subtracting matrices as well as when we're adding matrices, we need to check to make sure that they have the same size. And as you can see there from the question, we have a 3 by 2 matrix and a 3 by 2 matrix. So they're both 3 by 2, so we can perform the operation. And basically, when you are subtracting, it's just we go entry by entry. So let me go ahead and write that down and we can do it together. Make sure you check the size. And then and so let me go ahead and stop sharing here so you can see what I'm writing. And so you basically, I put a plus here in the 6 because I had made that a negative and it's a positive. So remember, we determined the size of a matrix, the number of rows times the number of columns. So we have a 3 by 2 and a 3 by 2. And so you're going to subtract entry by entry. So you basically subtract 14 minus 8, right? And that gives you 6. And then negative 2 minus, be careful here with the minus minus. So negative 2 minus minus, that's actually negative 2 minus minus is negative 2 plus 8, right? So negative 2 plus 8 gives you 6. And 2 minus minus 4 again, so that's going to be 2 plus 4 gives you 6. 12 minus 6 is 6. And then 3 minus minus 3, that's going to be 3 plus 3 is 6. And 8 minus 2 would be 6. So we've got another 3 by 2 matrix. And so that's the result there. The resulting matrix is a 3 by 2. And it's basically that matrix there. All right, so that's question 41. We're going to move on to question 42. And I know that you guys already have studied this well, and this is not difficult to do. You can also do this using, of course, a calculator. We're going to just go ahead and do some of these by hand. And so the next question I'm displaying there is find the following matrix product. And then for the product, basically, let me write down the matrix. We have a positive 1. I do it again. Positive 1. And then negative 4, 3, negative 1, 3, 3. And then we've got negative 1, negative 1, negative 1, 1, 3, negative 1. Okay, so basically here, let me stop sharing here so you can see what I have here. For the product, we have to change the, usually the product will change, the size will change, but we have to determine, first of all, if the product is defined. So here we have a 2 by 3 matrix, right? So 2 rows, 3 columns. And here we have a 3 by 2 matrix. We have 3 rows, 2 columns. And the way you determine if the product is defined, we have to check these here. You check that the number of columns equals the number of rows. So number of columns, we've got 3 equals the number of rows, 3. So then that is defined. So product is defined. And the resulting matrix is going to be a 2 by 2 matrix. Okay, so that's going to be a 2 by 2 matrix. So I'm just going to write down 2 by 2. So now we have to determine what that 2 by 2 matrix is going to look like. So the way you multiply matrices is you begin, and I'm just going to do the first two entries here, so for the sake of time, so we begin by taking the first row times the first column, okay? First row times first column, that's going to give us our first entry here, okay? So we will do that one. And then the second row times the first column will give us this entry here, okay? So we'll do that. And then, you know, just fill in the rest so you can do that on your own. But this is not too difficult. So how do we find row 1, column 1? So for row 1, column 1, we find as multiplying. So 1 times negative 1, 1 times negative 1, plus negative 4 times negative 1, plus 3 times 3. And so that's going to give us the row 1, column 1 entry. So that's going to give us 1 times negative 1, that's a negative 1, plus negative 4 times negative 1, that's 4. So negative 1 plus 4 is 3, and plus 9, that gives us 12, right? So you get 12 here. All right. And then we're going to do row 1, column. So we're going to do row 2 now, this one right here, row 2, column 1. Okay. And the way we're going to do row 2, column 1 is we take row 1, we take row 2, and we multiply it times column 1. So row 2, column 1, we do exactly that. Row 2, column 1, we take the second row, multiply times the first column. Okay, same way we did with row 1, column 1. So we take that and we do negative 1 times negative 1 plus 3 times negative 1, and then plus 3 times 3. And so that's going to give us, and we see, so negative 1 times negative 1, that's positive 1. And then plus, so we get 1 plus negative 3, that's a negative 2. So negative 2 plus 9, that's a 7. Right? So we got 7 here. And then, of course, to get the first row, column 2, you do exactly the same thing. Now you're going to go first row, column 2, right? You do exactly the same process for that, for this one, and for this one. So we have the same process. And what is that? So basically you take 1 times negative 1 plus negative 4 times 1, and so on. And so that should give you negative 8. I'm just going to give you here the answer so you can fill that in. But I already showed you how to do these two steps. And so for row 1, column 2, again, you take the first row times the second column, right? And then for row 2, column 2, you take the second row times the second column and do that same process. And that gives you the negative 8 and the positive 1 that you need, okay? But we will just allow you to do that for your own practice because I already showed you how to do these two, which is exactly the same. You just have to find the last two entries here, following the same process, okay? All right, let's move on to question 43. And so now that we practice with the product of a matrix, we have an application here. This is an actually really fun application. I found this one interesting, and we chose a 2 by 2 because it's just faster to get through, and also you don't really need, it's not about the length of the problem, but about the concept, mastering the concept. So we can really master it with this application. You don't have to deal with 3 by 3 matrices. I know that in the past the application involved bigger matrices, but this will suffice for us. So 43, it reads, a restaurant has a main location and a traveling food truck. Okay, so a physical location and then a traveling food truck. The first matrix A shows the number of managers and associates employed. Okay, so we've got, look at the first matrix. You have managers, we have managers and associates, and they are separated into the two types of businesses that we have, the restaurant and the food truck. And then the same managers and associates for matrix B, we have to pay salaries and benefits, right? So it says the second matrix B shows the average annual cost of salary and benefits in thousands of dollars, and we have to complete parts A through C. So the first part is we have to find the matrix product AB. So let's go ahead and find that product. But first we have to write the two matrices. So we've got 9, 2, 24, 6. And then the second matrix is 38, 21, 6, and 2. All right. And then I'm going to write some, remember, we want to find the product first. So let me go ahead and share there. Okay, so matrix A, this is matrix A, and this is matrix B. But matrix A, let me put matrix in. Matrix A, matrix B. So I'm gonna go ahead and write R for restaurant, F for food truck, and then we've got M for managers, A for associates, right? And then for matrix B, again, we have managers, associates, and we're gonna have salaries and benefits. And so just so you remember, I'm just gonna write down here the definition for each letter here. So M represents managers, and A represents associates. R represents the restaurant. F represents the food truck. And then S represents salary. And then B represents benefits. Okay. Now, part A says find AB. So AB, first of all, we have to check to make sure the product is defined. And so we've got a 2 by 2 and a 2 by 2. So the product is defined. You can check that the number of columns, right, is equal to the number of rows. And so the resulting matrix is going to be a 2 by 2. So we've got a 2 by 2 here. Well, now we have to find AB. And you follow the same approach I showed you with the previous example. We're going to take row 1, right, times column 1, which will give us the first entry here. So when you do that, you have row 1, column 1. Remember, we go 9 times 38 plus, right, 9 times 38 plus 24 times 21. And that's going to give us, and so I'll do the first two for the sake of time. So 9 times 38 plus 24 times 21. That gives us 846. And then to get row 2, column 1, so row 2, column 1, we get, so row 2, column 1, we take row 2, right, times the first column, column 1, so we get 2 times 38 plus 6 times 21, and that gives us 202. So here you can say, okay, we've got 846 here, then we've got 202, and then we need to find row 1, column 2. So row 1, column 2, you follow the same process. And to do that, row 1, column 2, so let's do that. So we've got 9 times 6 plus 24 times 2. And so 9 times 6 plus 24 times 2, that gives you 102. And then the last one is row, this one right here is going to be row 2, column 2. And so row 2, column 2, you get 2 times row 2, column 2. So 2 times 6 plus 6 times 2. And so you get 12 plus 12, right, is 24. So you get 24 here. And so that is the product AB. That's part A, product AB. And so there it is. Now let's go to the question, part B now. And part B reads, explain what AB represents and choose the correct answer below. Okay, so what does it represent? So we need to study it ourselves first, and then we can answer the question. What does it mean? Row 1. Let's study each row. Let's study what row 1 represents, what row 2 represents, what column 1 represents, and what column 2 represents, and that way we can get an understanding of what we have here. So when you look at row 1 of AB, you have 846 and 102. right? So what does this represent? Notice it's the restaurant, right? The restaurant. And then when you look at row one, you have restaurant. And then when you look at row one of the second matrix, you have what? The managers. And so row one represents of this right here, it would be the restaurant, right? Or, the restaurant of AB. Now row two will represent the food truck because, the food truck. So here you have the managers and the associates, right? Right, but the row one, this is all the restaurant, and row two, we have the food truck. What about column one and column two? Column one represents, notice we have the salaries, right? Total salaries of what? The restaurant and the food truck. So the column one represents total salaries, and column two represents total benefits of both the restaurant and the food truck. So if you understand that, right, we can write that down. Let's write it down because I think that's what really is going to help us answer the question. So what is row one? So row one, it represents what? Represents row one of AB represents the restaurant, right? And then row two of AB represents the food truck. And then column one of AB, and we're talking about AB, so what is column one of AB? So that's going to be what? The total salary, right? Of both, the restaurant and the food truck. So this is total salary. So total salaries. And then column two of AB, let me erase the paper so you can see. This is total benefits. And when I say total, I mean both the restaurant and the food truck, right? So total benefits. Okay, now, so this is how we interpret the product AB, right? So row one represents the restaurant of AB, right? The restaurant. And row two represents the food truck, right? And then column one, total salaries, column two, total benefits. And so that, let's go to the question and see which one makes more sense based on this explanation, which part will make more sense, which option will make more sense. So B says, explain what AB represents and choose the correct answer below. Row one of AB represents the restaurant and row two represents the food truck. Well, so far that's correct. Column one of AB represents total salaries. Yeah. And column two represents total benefits. So A looks right, but let's go to B, C, and D if we can eliminate them. Row one of AB represents the food truck. No, because that's not the right order. So B is incorrect. C, row one of AB represents the food truck. No, that's incorrect. And D, row one of AB represents the restaurant. Yes. Row two represents the food truck. Yes. Column of one of AB represents total benefits. No, that's incorrect because column one represents total salary. So the only one that makes sense is A. So the answer there to B is A. And then the next question, so the answer to B is A. A is the correct one. And then C, it says, according to matrix AB, what's the total cost of salaries for all employees, managers, and associates at the restaurant? Okay, so you can see from our matrix, at the restaurant, the total cost of salaries is going to be, let's go back to our matrix. And so we need to find total cost of salaries for all employees at the restaurant. And then we have to find the total cost of benefits for all employees at the food truck. Okay, so let's do the first part, right? And let's go ahead and look at our matrix. So the total cost of salaries for all employees at the restaurant, so we know restaurant is going to be the first row here, right? So salaries represents this one right here, because remember, it's the first column. And then the first row is the matrix of AB is going to be the restaurant. So it has to be this entry here, right? So total salaries, but remember this is in thousands. So total salaries at the for the restaurant. So total salaries, restaurant is going to be 846,000, right? So that's the first question, right? 846,000. And then let's go to the next question here. Total benefits for the food truck. So total benefits for the food truck. Well, remember the food truck is the second row, right? And so the total benefits for the food truck. So the second row is food truck, but now go to the benefits, which is column 2. So it's going to have to be this one, right? So total benefits for food truck. It's going to be and remember in thousands, so it's 24,000. So there we have the answers to parts A, B, and C. So we've got the answers there. And this is question 43. So we're done with 43. Okay. We're going to move forward to 44 now. And this one is graphing the inequality. Okay, these are not too difficult. Basically, we have the graph. First, we have to graph it, and then it says graphing tool. So when you do this on the computer, you're gonna be able to use the graphing tool. But right now, we're gonna do this by hand. So I'm gonna show you how to do it by hand quickly. So let me write down the problem there. And we have 2x minus 3y is greater than or equal to 18. Okay, so lower the paper there. 2x minus 3y greater than or equal to 18. We want to graph this one. Okay, so first step. So our objective is to graph the inequality. So first thing we can do to make it easier is solve for y. So let's do that. If I solve for y, I can do that by subtracting 2x from both sides. Right, that cancels the 2x on the left side. And then I have minus 3y is greater than or equal to negative 2x plus 18. Right? Now I divide by negative 3, both sides of the inequality. That's gonna make the inequality, the inequality will change direction, so it's going to become less than or equal to. And so whenever you divide by negative or multiply by negative, the inequality will reverse. So instead of greater than or equal to, it becomes less than or equal to. And so you've got y is less than or equal to. And here we have a negative divided by negative will be a positive, 2 over 3x. And then a positive divided by negative is a negative. So you've got 2 over 3x minus 6 is the inequality. Same inequality, just written in terms of y. Now, how do you graph this one? Well, we can graph. So we can write, let's graph the line y equals, instead of the inequality, just write y equals minus, not minus, 2 over 3x minus 6. Okay, so, and we're going to graph this one. Graph this linear equation. And the way to do that is just find the x-intercepts and the y-intercept. Well, it's actually one x-intercept and one y-intercept. So find the x-intercept and then find the y-intercept. Those are 2 points on the line that are going to be different points. That's all we need. So remember, for the x-intercept, the y is always 0. For the y-intercept, the x is always 0. So find the x and the y respectively. So we've got y. So we're going to let the y be 0 here for the x-intercept. So we've got 0 equals 2 over 3x minus 6. Now you add 6 to both sides. And then that gives us 6 is equal to, 2 over 3x. These negative 6 cancels. and then multiply both sides by 3 to get rid of the 3. So multiply by 3, and that gives you 18 equals, the 3's cancel here, 2x. You divide here by 2, and so that cancels the 2's, and so x is equal to 9, right? So you've got the 1.90 there, okay, for the x-intercept. For the y-intercept, you let x be 0. So you got y equals 2 over 3 times 0 minus 6. That cancels the 0 there, times the 2/3, y equals -6. And so you have 0, -6 as your y-intercept. So that's enough to graph the line y equals 2 over 3x minus 6. So go ahead and produce that graph. Remember, the equals means that the line will be bold. Okay, so it's going to be not a dashed line. When you use a graphing tool, make sure it's not dashed. And so here we have the 2 points, so 9, 0. So let's go ahead. Let's say this is 9. So that's going to be 9, 0. And then 0 minus 6. So let's say this is 0 minus 6. So you got this line. Remember, it's going to be a line, connected points. And then just draw the line. It's going to be bold, 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 right? And now, why bold? That's a good question, right? So once you have the line, now we have to go back to star. I'm going to call this star. And you want to graph the inequality now. Y has to be less than or equal to this line. This is the line y equals 2 over 3x minus 6. So follow the inequality. Y has to be below this line or equal to it or equal to it. That is why this has to be bold, because it can equal. So everything below this line or equal to it. So how do you graph that? Well, it's going to be all of this, right? And everything under that. So it's going to be all of them. So it would be all of that shaded, right? So let me erase this a little bit so you can see. So if you have, for example, usually when you're doing it in MyLabs, you have it's in a quadrant like this. And so it's going to be, all of that, right? Because it's below or equal to that line. Okay? So that is the graph of the inequality there. That's question 44. Let's move on to question 45. And so we're going to use the same graphing tools, graphing methods, I should say. Same graphing methods for number 45. Now this is an application. Now this is we're doing maximization of the objective function. So this is linear programming. And basically we're trying to maximize the objective function z is the function that we're trying to maximize. And subject to the constraints x minus 7 less than or equal to 7, 5x plus 3y less than or equal to 75, and x is greater than or equal to 0, and y is greater than or equal to 0. So immediately the last two constraints, the x being positive or equal to 0, and the y being positive or equal to 0, that puts us in quadrant 1. So we can't graph it anywhere else because we're in quadrant 1. So that gives us this quadrant here, Q1. Now we just have to focus on the other constraints, the x minus y less than or equal to 7, and the 5x plus 3y less than or equal to 75. And that, we have to graph those two lines. The way I did for number 44, we will graph the lines. We will identify the feasible region, where, because the constraints will tell us where that feasible region is. We have to find the corner points to close, see if the feasible region is bounded or unbounded. And then we're gonna, once we find the corner points, we're gonna plug them into the objective function, and then we're gonna see which one of those points maximizes that function. Now, all of that, it takes a lot of time, but it's not difficult. We just have to go step by step. And so first, let's write the, now for the sake of time, since you know how to find the x-intercepts, I already showed you in the previous problem how to find the y-intercepts and how to graph the inequality. So I'm going to be skipping a lot of the middle steps to get to the heart of the problem, just for the sake of time, because we did it in problem 44. Problem 44 was to introduce you to the process of graphing the constraints, and then problem 45 is an application. Okay, so let's do it. So 45, it says maximize maximize the objective function as z equals 5x plus y. And then subject to the constraints are x minus y less than or equal to 7, 5x plus 3y less than or equal to 75, x greater than or equal to 0, y greater than or equal to 0, okay? And so what do we have to do? Graph the feasible region, right? And then maximize value C is at what corner point. So basically we're gonna find, we have to first graph. So I'm gonna create, well, first step is that we need to solve. So I recommend that we write the constraints in terms of y. This is going to help us make it easier. Okay, so what are the constraints? So the constraints are, so this is the first step. So we've got x minus y less than or equal to 7. And then another constraint is 5x plus 3y less than or equal to 75. So if you solve for y, just solve for y. And that's going to give us, so if you solve for y, let's do it. So minus x, right? That's going to cancel the x here. So we've got negative y is less than or equal to minus x plus 7, and then divide by minus 1 to make it positive. So that's going to be y. And since you're divided by a negative, this becomes greater than or equal to x minus 7, right? So this is one constraint written in terms of y. So x is greater than or equal to x minus 7. Now, same thing here. When you do the math here, let me just, for the sake of time, you should get y. So, well, let me go ahead and do it. Minus 5x, right? That's going to cancel that, and then you get 3y is less than or equal to minus 5x plus 75. And then you divide by 3, all of it. That gives you y is less than or equal to negative 5 over 3x. And 75 divided by 3 is 25. So 25. So this is the second constraint. Okay. So you want to list the constraints in terms of y. So constraints. The constraints are y is greater than or equal to x minus 7, right? And y is less than or equal to negative 5, 3x plus 25. And I may need another red pen because I feel like this one is getting a little bit weak. My red pen. Give me a second, please. Let me get in case my backup red pen. Okay, now we have to graph the constraints, right? Remember, don't forget the x greater than or equal to 0 and y greater than or equal to 0. So graphing the constraints is very important. So how do we do that? So we need to graph the constraints and graph the line y equals x minus 7, and then also graph the line y equals negative 5 over 3x plus 25. So graph those two, and then to do that, you find the x and the y-intercept, right? And so what is the x and the y-intercept here? So find the x-intercept and find the y-intercept of each one. You know how to do that, so I'm just going to write down here, what is the x-intercept? So remember, to find the x-intercept, you want to let the y be 0 and solve for x, right? And so for this one, the x-intercept is the point, I'm just going to give them to you, 7, 0, okay? And then the y-intercept, for the sake of time, we have to find, because you already know how to do it. Remember the y-intercept, you let the x be 0 and find y. So the y-intercept here is going to be 0, negative 7, right? Same thing for the second equation here, for the linear equation. You want to find the x-intercept. Okay, and when you do that, for the x-intercept, you get the point 15, 0. Okay, 15, 0. And the y-intercept, you get the point 0, 25. Okay, so make sure you do that on your own because you know how to do that. I showed you how to do that, and I'm sure that from class you already know from your classes how to do that. Because this is a long problem, we have to save time. Okay, so once you have the 2 points for each line, remember we have to find the 2 points, and the x-intercept and y-intercept, they work beautifully. Also for this equation, for this linear equation, you find 2 points, the x-intercept and the y-intercept. Now we're gonna graph the constraints. And after we do that, let me move to another paper so I can graph that. Okay, and remember that we are in quadrant 1. So we're in quadrant 1 here, and we have to plot the points 7, 0, and so we're trying to maybe if I go all the way to, let me take a look. So I have to go, yeah, okay, so we can go. So another way to 30 here, also here. All the way to 30. Okay. Okay, that's 0. Okay, and let's plot the points 7, 0, and then 0, -7. And oh, you know what? Sorry about that. Give me just a second. Well, yeah, even though we are in quadrant 1, but because the points I found, I have to extend it here, right? Because I have the y-intercept is actually 0, -7. So we have to go below, but remember, we're in quadrant 1 because of the constraint. So, but I do have to extend it. Okay, sorry about that. All right. Okay, so here we have, so let's plot them. So we have 7, 0. So 1, 2, 3, 4, 5, 6, 7. Here's 1 point, 7, 0. And then 0, -7. So -1, 2, 3, 4, 5, 6, 7. Where's the other one? 0, -7. Okay, and then we have this, this is for the line, so we can connect them, right? And this is going to be the line, an increasing line going this way. This is y equals x -7, right? Line is increasing. And make sure that you can see the whole thing. Okay, that's the first line. Now the second line, let's draw. I'm going to use a different color for the second line. I'm going to make it blue. That one is going to be the line y equals -5/3x plus 25. So it's a line that is decreasing, right? So 15, 0. So here's 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 1.15, 0, right? And then 0, 25. So up here, 1, 2, oh, remember this is 30, so I can just go down 1, 2, 3, 4, 5. So it's going to be right here, 0, 25. Okay. And so you connect the two, right? Like that. Now remember, this line is decreasing, right? So this is going to be y equals -5/3x plus 25. All right. And now remember your constraints. So what are the constraints? The constraints are, so we've got 2 of them already, but these 2, but also remember, so I'm just going to write them here so you remember what they are. Y has to be greater than or equal to x -7, and then y has to be less than or equal to -5/3x plus 25. And then we also know that x is greater than or equal to 0 and y is greater than or equal to 0. So because x and y are positive, we have to be in quadrant 1, right? But remember, so this is the red line. So let's see. This is red. I'm going to put red here, right? And then this one is the blue, so I'm going to put blue. And so what is it saying? We have to identify the feasible region So what are the corner points? Well, first of all, we're not there yet, right? But we have to find the feasible region first. So it has to be above the red, right? Because it's greater than or equal to, remember, this is the red. So you have to be above this red line. And then you have to be below the blue, so below the blue. But you also have to be greater than or equal to 0. So it's basically this region here, right? It's right here. So you have to be, X has to be positive and Y has to be positive. So that forces, and then I have to be below the blue, right? Because under the blue, remember, less than or equal to, so below, but above the red. So it's all this, right? So there's my feasible region. Now, what are the boundary points? So the boundary points, I have all of them except I'm missing this one because remember this is a boundary point that I don't have. This is a corner point as well. So what are the corner points? We have to find this one, the intersection point, right? And so, but I have to find it. I don't know what this is, this one. So in order to find it, we have to set the two lines equal, these two, because the blue and the red equal there. So if you set that up, you can find the place where they intersect. So let's do that, and then we can find the intersection point. Okay, so intersection point is found by setting the two lines. So intersection point. So we have to set x minus 7, like this is what so the two linear equations, you set them equal, right? Because they intersect here. So x minus 7 equal to -5 over 3x plus 25, right? So equals to -5 over 3x plus 25. So when you set them equal, you find your intersection point. And so once you would do the math there, let's go ahead and find x. So make the x positive. I'm going to add 5 over 3x to both sides, right, to make the x positive. And so then you have 5 over 3x, right, plus, so you've got x plus x, right, plus x minus 7. So you add, and then that gives you 25. And so this one you can write, well, 5 over 3x plus 3 over 3x, so to make it, the same denominator, minus 7 equals 25, right? So you make the x the same denominator so that, you can say, so you can add now. So 5, that gives us 8x over 3 minus 7 equals 25. And then you add 7 to both sides. So plus 7, right? And that cancels the 7, and so you get 8 over 3x equals 25 plus 7 is 32, right? And so you can multiply by 3 to get rid of the 3 here. And then you get 8x equals 96. And so 8x equals 96 divided by 8. And that will give you 96 divided by 8, 12, right? So that gives us 12, x equals 12. Okay, so when x is 12, then how do you find the y? You plug it into any of the equations, choose the easiest one, x minus 7. So y equals 12 minus 7, that gives you 5. So y equals 5. So the intersection happens at 12, 5, right? So you can come here, and then you can write this is 12, 5. And so what are the corner points now? You can identify them. So the feasible region is shaded there. So the corner points, let's identify the corner points. So what are the corner points? So corner points, I'm going to write them here. Corner points, we've got this is 1, 0, 0. And then this one is another one. So 0, 25. Intersection of point is 12, 5. And then this one, 7, 0. Right? So you got four corner points. And now you need to see which one is going to give you, which one is going to maximize, which of those points will maximize the objective function. So you just basically take the corner points, and now you have the objective function z equals 5x plus y. And so you need to evaluate it at each corner point. So evaluate at each corner point. And when you do that, you plug in the x and the y, you will see that this happens at 12.5. So it maximizes, z is maximized. I'm just gonna write the answer here because this, you basically just do, the way you evaluate it is you plug it in, like for example, 5 times 0 plus 0 gets 0, and then the next corner point, 5, what was the next corner point? 12, 0, 25, so this is 0, right? 0 plus 25, that will give you 25, right? And then the next corner point, 5 times 12 plus 5. So that's going to give you 65, right? And then 5 times 7 plus 0, 35. So notice that the one that maximizes the objective function is the intersection point. So z is maximized at 12.5. Okay, that is where the objective function is maximized. Okay, so that was a really long problem, but that's basically the process there. Okay, all right, let's move on to the next one. I don't want to make this video too long, but then again, this problem did require a lot of steps. Okay, 46. We move on to probability now. And it says Tammy goes shopping and sees 3 kinds of shoes: flats, 2-inch heels, and 3-inch heels. Okay, so let me write that down. So we've got the flats, the 2-inch heel, and then the 3-inch heel. The shoes come in 2 shades of beige. Okay, so the light and the dark. So then that's also, so light, beige, and dark beige. Okay. And black. Oh. So, well, wait a minute. The shoes come in 2 shades of beige, light and dark, and then also black. Okay, so then we have, but it's 2 shades of beige and black. If each option has an equal chance of being selected, find the probability that the shoes Tammy buys are beige. Okay, so light and dark beige. So this is basically the beige and black. So I'm just writing down the choices here. And so we're looking for the probability that the shoe Tammy buys are beige. So basically, we are looking at only the beige and the height, right? So what are our choices? So what's the probability that the shoes are beige? That's what we're looking for. So let me write down. So probability that the shoes are beige. Find the probability that the shoes are beige. 2 shades of beige and then also in black. Okay. So we're just looking for just the probability that they are beige. All right. And so I wrote down some of the, so what do we have? We have flats, 2-inch heels, 3-inch heels, and then we have light and dark beige and black. And so remember probability, the way it works is we have to find the sample space, right? So the sample space is the set of all possible outcomes, right? And then we look at an event. And so we have basically the sample space. How many possible outcomes can we actually have? Well, if you ignore color, Tammy can choose from 3 kinds of shoes, right? I mean, she can choose from 3 kinds of shoes and from 3 different colors: light, dark, light beige, dark beige, and also black. So okay, the way I look at this is that Tammy can choose from three kinds of shoes, right? If we ignore color. But now, if we take color into account, it says that the sample space has to include also three different colors, right? So we have to take that into account. So three different colors. And that is, remember, the light beige, the dark beige, and the black. So then the total possibilities I get in the sample space, so S is actually 3 times 3. Remember, if we use the fundamental counting principle, so you've got 9. So how many elements do we have in the sample space? 9 elements, okay? So we've got 9 elements in the sample space, and now if we look at the event that the shoes are beige, we have to consider the heel, and in the beige we have two options, right? So we have the dark and the light. So then let E be the event. I have to define, let E be the event that the shoes Tammy chooses are beige, right? So that's what we're looking at. And so E, what are the possibilities? Remember that you can have basically, if we look at the heel size, we have the flats, the 2-inch and the 3-inch heel. So you can have flat, right? And then you can have the dark beige. That's one option. And then you can have the flat, right? So I'm going to do flat again. And then you have the light beige, right? And then you can move on to the 2-inch heel. So the 2-inch heel with the dark, and then the 2-inch with the light beige, right? And then moving on to the 3-inch heel, you can do 3-inch dark, and then 3-inch dark, light. And so that is basically what we have, right? Because, so how many elements do we have in this event of choosing beige? Remember, you have to take into account the heel size. So we have flat and dark beige, flat and light beige, and then you got the 2-inch heel with dark beige, 2-inch heel light beige, 3-inch heel dark beige, and 3-inch heel light beige. So we've got 1, 2, 3, 4, 5, 6, right? So you've got 6 possibilities that she's gonna choose the shoes are beige. So then, to find the probability of this, we have to remember the formula for probability is the number of elements in the event E divided by the number of elements in S. So the probability of E, right? You can write it as the number of events in E divided by the number of events in S. And so we've got 6 over 9, right? Which gives us, if we reduce 3 goes into 6 twice, 3 goes into 9 3 times. So 2 over 3 is the probability that the shoes will be beige, right? So that's the answer there of question 46. All right, let me see. So that one, it's just setting it up right. 46, right? Now 47 has similar question. It says Christina Karkanova invites 14 relatives to a party. Okay. Her mother, 3 aunts, 4 uncles, 3 brothers, one male cousin, 2 female cousins. And if the chances of any one guest arriving first are equally likely, find the probabilities that the first guest to arrive is as follows. So we're going to look at for the probability of a brother or an uncle. For A, the probability that a brother or an uncle will arrive first, and then a brother or a cousin, and then a brother or her mother. Okay, so let's do that. So first, let's write down the details here of the problem. And let me fix this chair because it's a little bit far away from the computer. In just a second. I do know this chair is kind of doesn't want to move. Here in a second. There we go. All right, and let's write down. So it has we have Christina. Let me write down some of the details here. So 47. Christina invites 14 relatives, right? To a party. And then what are they? So her mom, her mother, 3 aunts, 4 uncles, 3 brothers. I'll share in a moment. 1 male cousin, 2 female cousins. Okay. All right. Now we want to find the probability that the first guest to arrive is a brother or uncle for part A. So a brother. Keep an eye on the word or, uncle. B, a brother or a cousin. And C, a brother or her mother. Okay. Now, let's go ahead and answer these. They're not difficult. So we're going to use the same formula for probability. We find the sample space and then we can, so for part A, a brother or uncle. First, we have to see what is the probability that a brother, so if B is the event that a brother is the first guest, what's the probability that, how many outcomes do we have? So basically, we have 3 brothers, right? So how many possible outcomes? If B is the event, so we can define, let B be the event that, so let's do that, right? So I'll use capital B for brother, right? So B is the event that the brother arrives first. So brother arrives first. And then cousin, and we will, well, and S is the sample space of the total number of relatives is 14. So S, how many possibilities do we have? We have 14 relatives attending. So S is basically, so the number of outcomes in B is going to be 3. And the number of outcomes in S, remember S is a sample space, is 14, where S is a sample space. We have 14 attendees. So the number of outcomes in the sample space is 14. So for part A, it's basically, where's my red pen? I don't see it anywhere. Don't know what happened to my red pen class. I'm sorry. I wanted to use my red pen. But it's somewhere. It left us. I don't know where it is. Okay, so I'll use black for a different color. Okay. So for A, the probability, we have to look at the probability that the brother will attend first is gonna be the number of outcomes in B divided by the number of outcomes in S, so that's 3/14, right? So you have 3 brothers. And then we can look at also the probability that, because remember, it's a brother or uncle. So when you look, let's say U is representing of the uncle to arrive first. I'm gonna put U here. So uncle arrives first. And so now the probability that the uncle arrives first, how many uncles do we have? 4. So it's going to be 4/14. So that's 2/7 when you divide, right? When you, what do you call it? When you reduce. Okay, but now we're looking for brother or uncle. So we have to use the formula for the union. So the probability that it's going to be the brother or the uncle, union uncle. I'm going to use this U for uncle, okay, to distinguish the union symbol. It's the probability of B plus the probability of U minus the probability of the intersection of the two. Remember that formula, right? And so you know that this is going to be 0 because they cannot arrive at the same time. I mean, you can't have a brother and uncle happening together at the same time because they're different persons, right? I mean, you can claim, well, they can arrive together. No, there's only one that's going to arrive first, either one or the other, because they're two different individuals, right? So now this is going to be the probability of B, 3 over 14, plus the probability of U, which is 2 over 7, minus this is 0 because that doesn't apply. You have to assume that two individuals cannot be the same person, right? So, I mean, that just makes sense. And so now you add these two, and if you add these two, you need a common denominator. I wish I had my red pen. Where did it go? Give me just a second. Let me find it. Because I really do need it. Don't know what happened to it. Where did it go? No, I have some more here. It's weird because oh, here we go. This is probably the old one. Let's see. So I'll try this one. Sorry, just looking for my red pen. All right, so that's gonna give us, because you need to find a common denominator, so multiply this by 2. And that's gonna give you 3 over 14 plus 4 over 14. That gives you 7 over 14, right? And that can reduce to 7, goes into 7 once, 7 goes into 14 twice, so 1/2. So then you can say that that's 1/2, right? 1/2, that's the probability that a brother or uncle will be arriving first, okay? Now, the same approach is true when you look at the probability of a brother or cousin. So for brother or cousin, you have to just see, okay, how many cousins do you have? So we have one male cousin and two female cousins. So if it's going to be a brother or a cousin, well, you know the probability of a brother is going to be, we found that in part A. Probability of a brother arriving first is 2 over 7. And so brother or cousin will be the probability that it's a brother or a cousin. How many cousins do we have? 3, right? So it's going to be the the probability of a brother, 3 over 14, plus how many cousins do we have? 3 also. So it's going to be 3 over 14 plus 3 over 14, right? You see? So now that we have this problem here, so we can answer part B really easy, right? So we can see that. So the probability, so part B, I'm going to write it here. So part B, the probability that it's a brother or cousin, remember, you have the probability that it's a brother. Actually, I need more room. Let me go over here. So brother or cousin, so B, a brother or a cousin. Remember that the probability that it's a brother is going to be, we've got how many brothers? We said 3 over 14. And then probability of a cousin, I'm going to just write C for cousin. We also have 3 over 14, right? And now remember the formula though, for probability that it is a brother or cousin arriving first, you have to use this formula. B plus probability of C minus the probability of the intersection. And so we've got 3 over 14 plus 3 over 14 minus 0, because that's just 0. So that's 6 over 14. And that's going to be 3 over 7, right? For the answer to B. And so I think you can see that the probability of a brother or her mother, that's just going to be 3 over 14 plus 1 over 14, right? Because there's only one mother. So for C, you can answer C here. So the probability that it is it's going to be the brother or her mother. So you can say brother union M for mother. It's going to be the probability of B plus the probability of M minus the probability of B intersected with M, which you know is 0. So the probability that it is a brother is 3 over 14, her mother is only one mother, right? There's only one. That goes away. And so that's going to be 4 over 14, which is 2 over 7 for the answer. Okay? That's 2 over 7. So that is the probability. That's question 47. So those probability questions, just use the formula and make sure you identify the sample space and the event that you're looking at, and it should be very straightforward. Okay? All right, so that's question 47. Let's go to the next question here. 47, 48. It says a single fair four-sided die is rolled. So it's four-sided and it's fair. So what are the possibilities? 1, 2, 3, and 4. Find the probability of getting a number less than 3. So basically getting a 1 or a 2, right? 1 or a 2. But we can't say or because both apply. So they both apply, so we have to actually say and, 1 and 2. Right. And so basically what we can do here, and so the probability of getting a number less than 3. Okay, so let me write 48. It's find probability of getting a number less than 3 when you have a four-sided die, a fair four-sided die. So the sample space is, so it's four-sided, 1, 2, 3, 4, right? So getting a number less than 3 is going to be, there are two different rolls, right? So there are two different rolls less than 3. And that's a 1 and 2. Okay, so that's how many possibilities? 2. So the probability of getting, let's say that E is the event of getting, I'm going to define E as the probability of getting a number less than 3. So the probability of that is going to be the number of elements in E divided by the number of elements in S, the sample space. So E has 2, right? Because you can get two different rolls that are less than 3, 1 and 2. So 2 divided by 4, that gives us 1/2. That's the probability of getting a roll number that is less than 3. Okay? 1/2. 48. Okay, 48 is done. Let's move on to 49. And we move on to expected value. So both of questions 49 and 50 are finding the expected value. And so you can see how, same thing, both of the problems are similar. So how do you find the expected value? You find there's a formula, and it's a very straightforward formula for expected value. Let me go ahead and have the table here. And so I'm going to show you 49, and then with 49, you can do 50. So I'll show you 49 so that we don't make this video way too long, because I know we already made it very long, but we can't make it shorter. I mean, these problems take time. And so remember, the probability cannot add up to a number less than, it has to be between 0 and 1, right? So 0 0.1, 0 0.2, and 0 0.2, 0 0.3, 0 0.4. And when you add up probability, it has to add up to 1, right? When you take all the probabilities, it should sum up to 1. And basically, this is the idea here, right? And so let's see. So 2, 3, 4, 5. We'll stop sharing here. So what is the expected value? The expected value is found by taking the value of each random variable, 2, times the probability of it occurring. So you take 2 times 0 0.1, and then 3 times 0 0.2 plus 4 times 0 0.3 plus 5 times 0 0.4. So this one's pretty straightforward. And when you add it all up, the expected value should give you 4. Okay? And so that would be 49. The answer is 4 when you add up everything here. And 50 is done the same way, so you follow the same formula. So 50, same process. Let me just write it here. And so that completes our course review. So we've gone through the 50 questions, and that is awesome because there were many, many problems in this review. So I hope that you do very well on your final exam. Thank you for watching. Now I just have to look for my red pen. I don't know where it went, but good luck and thank you for watching. So I'm going to stop here.